all 20 diagonals are drawn in a regular octagon, at how many distinct points in the interior of the octagon do two or more diagonals intersect? Well, here's a little shortcut to simplify the problem. Now, one approach is just to list the different cases of diagonals, and by cases I mean you can have a case where diagonals are one away, like skipping one vertex before hitting the next. You could also have this case and likewise, and counting these cases yields the number of pairs of intersecting diagonals fairly easily. However, this is not the most efficient way to approach the problem. And what we are going to do is switch back to the pen, count the number of pairs of intersecting diagonals. First, number of pairs of intersecting diagonals. And I will explain why this is not equal to the number of points of intersection. So the number of pairs of intersecting diagonals does not equal the number of points of intersection, and I will discuss why this is the case going forward. So to determine the number of pairs of intersecting diagonals, any pair of intersecting diagonals, let's consider an arbitrary one, say these two. This is a set of 4 points. This can be made in one-to-one correspondence with the set of quadrilaterals whose 4 points are on the outer perimeter of the octagon. So the number of pairs of intersecting diagonals is simply a choose 4, where this gives us the number of ways to pick 4 points out of 8. Okay, moving forward, we have that so this is a choose 4, and this evaluates to 8 times 7 times 6 times 5 divided by 24, and doing the calculation, this is 70. And many people would be tempted to pick C and move on, but this isn't correct, and I'll explain why. Now this gives us the number of pairs of intersecting diagonals, as I've been reiterating, but this doesn't quite this overcounts, because consider this case, the case where we have 4 diagonals intersecting in the center. Now, this method of counting would count this quadrilateral, but it would also count this quadrilateral and several others. So this quadrilateral, but also this quadrilateral. And I know that's messy, but for now it serves the purpose of illustrating that you can have overcounts, that there are multiple quadrilaterals that correspond to this intersection point. So, and there are 2 cases we need to subtract off of. First, this case where they all intersect in the center, that would be, this is being counted how many times? 4 choose 2 times, because we have 4 diagonals, and for every pair it's being counted once. So it's being counted 6 times, and we obviously only need to count it once. So we need to subtract 5, and this gives us 65. Now there's yet another case to account for. So it's not equal to 8 choose 4 anymore, but 70 minus 5 is 65. So far, let me just write over here, we have 65. Now, we have the second case of 3 diagonals intersecting, and this is overcounted because this is counted 3 times. For 3 diagonals, we have 3 choose 2 ways to count this, and this is being counted 3 times. And if you rotate this particular intersection 45 degrees, you could do that 8 times for every vertex of the octagon. So there are 8 cases in which we are counting 3 times. So we need to count these cases only 2 times, which gives us 65 minus 16, which is 49, or A. And since we're on the AMC, we can be sure that we can be sure that it's A, because of we don't have any lower answers for us to subtract overcounts of. So the answer is A.